Greetings everyone. I'm going to demonstrate our model of a bridge made for the final project in computer graphics at USF Fall 2020. This bridge was completely modeled in Blender 2.90.1. Here you can see the finished model. This bridge is based, at least partially, on an existing bridge in Dhaka, Bangladesh named Hatirjhil Bridge No. 2. We chose a bridge since it was fairly complex but was still a non-organic and industrial structure where we could take advantage of the visual symmetry. The reason I chose this bridge was that I was familiar with the look of this bridge, having grown up in Bangladesh. I say partially based since we decided to leave out a few details in the name of simplicity, but we can just leave that to artistic creativity. Let's talk a little about the pre-creation process and the planning. We looked for various reference images on the internet. One of the most important factors in finding reference images was to obtain images from perspectives that lended themselves to capturing better modeling information, such as views from the side that were taken straight on to provide better information on proportions of the side beams and road curvature. In retrospect, it might have been better to select a more globally famous bridge to model since there would be more reference pictures available, as it was pretty hard to find appropriate pictures for this particular bridge. The quality of some of the pictures, especially after zooming in, was also not the most optimal. Therefore, we decided to trace out some of the more particular shapes. We also made them black to provide more contrast. We could then use this image to help us model the sides of the bridge much better. Here is how we created the bridge sides using the reference as a backdrop. You can see how we are smoothing out the kinks while more or less keeping true to the actual dimensions of the reference. We also looked up bridge dimensions, such as span and deck width, on structureae.net. This provided a basis for modeling since it is always easier to start off the model with actual dimensions to make things like calculating angles and perspective easier later on. Additionally, we could study different parts of the structure to identify textures for later use. We could look for textures that looked most like what we were seeing. This also helped us separate the different structures and substructures. Speaking of structures and substructures, here you can see the different objects in our Blender project. Blender allows you to separate objects into collections, and we have separated the objects into sensible chunks that pertain to localized areas of the bridge. Here I am showing you the different parts that were combined together to make the full bridge. Now let's talk about the actual building process. We use the modifier tools in Blender to help us build this bridge. Modifiers are basically transformations that can be done on objects without affecting their actual topology. Things such as introducing new faces or vertices in existing objects or repeating a certain object a number of times. The mirror modifier was the most useful since we could take advantage of the various existing symmetries of the bridge. We could only model a certain quadrant or corner and not have to worry about repeating the specific details on all sides. Here you can see how the mirror modifier was used to duplicate the poles on the sides of the bridge. The curve modifier allowed us to make objects follow a path or curve. This was really helpful when designing the railings for the bridge, since we could make them follow the road curve that we already made. This, together with the array modifier, helped us fine-tune the details of the railings. The array modifier is pretty self-explanatory. It allows you to create repetitions of the same object with optional offsets in its location. Here's the array modifier in action to create the poles that we saw earlier. The Boolean modifier helps you combine, subtract, or intersect two different objects. This was very useful when making the poles on the sides of the bridge. Since they needed to stop at the top of the side curvy parts, we were able to subtract the top from the poles. Otherwise, we would have to manually adjust and resize all the poles to make sure they don't go through the top. Here, you can see the Boolean modifier subtracting the pole's geometry from the top part of the bridge. We had to create an extended version of the top part temporarily to provide geometry to be subtracted from. The subdivision surface modifier was very useful to introduce smoothing to a lot of the otherwise flat surfaces. This basically introduces more faces on the surface of the object and can help smooth things out. It helps make things look more realistic and worn out. With all of these, there were some difficulties in being able to understand exactly what they did in order to apply them. One of the main challenges was to be able to think in terms of vertices, edges, and faces separately while modeling. Blender has selection modes for all three where it represents them differently on the viewport. Being able to control and see exactly what one wanted to select and move or transform is very beneficial, although a little challenging at first. Now let's talk briefly about lighting. Lighting was one of the most important parts of the modeling process, since without proper lighting, a really good model would still look bad in the final render. Some of the challenges pertaining to lighting was to put lights in sensible places to help show the final render properly. We even put a light as sunlight up on the top at an angle for showing shadows of the sides on the bridge. In the end, it was difficult to understand what the lights and the various settings for them, such as the intensity, color, and shadow settings, did, and how they added to the final result. But once we tried to render a few times and understood how lighting clicked in with everything, we were able to more or less implement the lights correctly. Finally, let's talk about textures. As I mentioned, we obtained various free textures for roads, pavements, concrete, and aluminum from the internet. One of the hardest things to understand was UV unwrapping for simple and complex objects. UV unwrapping literally thinks of an image or texture as wrapping around a 3D object. Learning how to mark seams in complex structures, such as the curvy bridge sides, to allow the automatic UV unwrapping to work properly was also a challenge. We also use PBR textures, which come with variations with different information about the same texture, including normal, bump, and roughness values. Here you can see how we use the Blender node editor to use a grayscale, normal, bump, and roughness values to shade textures to add realism. For the render, we wanted to set up the environment to be somewhat pleasant to look at, so we modeled a plane with some fluctuations to represent the river and added a skybox, well, more like a sky cylinder. And here's the final render. Enjoy! The full Blender file is available on GitHub. The links are in the description below.